So, first, before we get into, if you look at the first page of your notes, guys, quiet, paying attention, please. If you look at the first page of your notes, you can see there's really not a lot to fill in on this, just a lot of explanation, things we need to talk about. So, of course, when we are going to start making the inverse today, when we start working on that, we're back to, as you can see, the diagonal ones and the zeros. That's why I said it's kind of Gauss-Jordan-ish, okay? So the diagonal ones and the zeros, of course, we refer to those as the identity matrix. Obviously, the I2 is your 2 by 2, I3 your 3 by 3, so on and so forth. Now, why is this important? Remember, if you multiply a number by 1, 10 times 1 is 10. If you multiply a matrix by its identity, you get the same matrix. So this is going to come into play when we check to make sure we actually have the correct inverse matrix when we get to it. So I was like, I'm not going to make you do the work for this. Clearly, I just copied it down. Okay. So just showing you or proving to you, if you multiply your identity matrix to the matrix, you end up with the same thing. And remember, they're multiplying this. They're doing that row and the columns. So they didn't get, I'm not going to get crazy. We're not going to write all the work. We're not going to get carried away with it. But clearly, if you multiply by the identity, you end up with the same starting matrix. So here's where it gets fun for us, is really this last note. If you multiply A and B together and get your identity, and it has to work the opposite direction. Because remember, the first one, you'd use the rows of A. Second is the rows of B. They are not going to be the exact same calculations. You have to get the identity on both products. That's how you know that you do have the correct inverse. That is how you check it. Now let's get honest. Are we all going to check these every time?
No way.
Probably no way. Myself included. But we should know how to check it. So verify it's the inverse. So we're going to do A times B, and we're going to do B times A. You do have to calculate both directions. Now, as long as we have no errors in our math, which we would never have in here, okay, we should end up with the identity matrix, the diagonal ones and the zeros. Now, when you do A times B, remember it's rows of the first matrix. So, rows of A, first row A, 2 and 1, bottom row A, 5 and 3. And then it's the columns on B. So first column B, 3, negative 5. Second column B, negative 1, 2. I think it was Alex that said the Punnett square. That's what I think of now when I look at these. 3 times 2, 1 times negative 5. 5 times 3, 3 times negative 5. I'm going to do the other calculations. 2 times negative 1, 1 and 2. 5 and negative 1, 3 and 2. And as long as we haven't made any calculation errors, we should have the 1, 0, 0, 1. And I think it's looking pretty good. 1, 0, yep, like it. Now, it has to work in both directions of multiplication. And remember, the reason why you have to do it the other way, you can't just be like, isn't it going to be the same? Well. Remember, B times A. Now you're using the rows of B, columns of A. So you want to show that it works for both situations. So look closely. Rows of B. First row of B, 3, negative 1. Bottom row B, negative 5, 2. And then I want the columns of A. So first column A, 2, 5. Second column A, 1 and 3. And again, as long as we don't have any calculation errors, it should turn out to be the 1, 0, 0, 1. 2 times 3, negative 1 times 5, negative 5 times 2, 2 times 5, 3 times 1, negative 1 times 3, got it, and negative 5 and 6. Looks good to me. I think we did all right. So as long as you get that diagonal ones, the identity matrix, and the zeros on both directions of multiplication, it is the inverse. That is how you would check it, which I'm sure we're all going to do. Moving on. Okay, well, let's talk about how to find the inverse of a 2 by 2. It's super easy. I promise this all looks kind of crazy. First calculation you're going to make is this AD minus BC. Now also too, and this is going to come into play especially when we get to the calculators. Notice, you know this negative 1 means the inverse, A inverse. This is how you calculate it. So AD, this diagonal, minus the product of the other diagonal. So that's the first thing I'm going to do is multiply on the diagonals and subtract it. Piece of cake. Okay? Now, check the order. You have to kind of rearrange this. Let me erase all my red here because I'm going to remember. So you have to rearrange this, meaning notice A and D have switched spots. So you just swap them. Okay? The top left moves to the bottom right. B and C stay where they're at, but you have to switch their signs. So it looks kind of crazy with all the letters, but I promise it's really simple. First thing I'm going to do is the AD minus BC. So flip the page and let's do it. I don't know what's happening over there, Connor. Okay, so AD minus BC, Lord help me. All right, so I'm just going to do the calculations, of course. So I'm doing 4 times 3 minus 2 times 5. And you can do that in your head. So first calculation. So I'm going to click it back a slide. So when I go to make my inverse, I am going to rearrange it here. I'm going to do all of this stuff. Then I'm going to times it by a half, because we got 2 for this. So then I'm going to distribute the 1/2 through it. Okay, next step. We're going to do a little rearranging. I got to erase all the blue stuff here so we can see it. So the 4 and the 3, they just simply switch spots. 3, 4. That diagonal just switches. The 5 and 2 stay where they're at, but you switch the signs on them. So I'm going to make this -5, -2. And my final answer, I have to distribute 1/AD minus BC through here. So now I just times all of those numbers by a half. So I'm going to have 3 halves, half times -2, -5 halves, half of 4. And there's my inverse. Okay. So very simple. You just have to remember this diagonal just switches spots. The other diagonal, they stay, but you change the sign. That's the calculations. I don't think we need to do any more 2 by 2s. Now, as always with all this matrix stuff, 2 by 2 is simple. 3 by 3 is where it gets dicey on us. So let's talk 3 by 3, shall we? So this is really kind of for generic, like even if you had a 4 by 4, 5 by 5, which we're not going to make you do by hand, but we're going to get into 3 by 3. So first, they do need to be square, of course. And again, 3 by 3 is the largest we're going to do by hand in here. So write the n by, boy, this is where the n by 2n matrix that consists of the matrix A on the left and the n by n identity matrix on the right. And that gives you the first matrix and the identity. And you'll see this, I'll do this in a second. I'll set it up for you. Now here's where it gets fun. Row reduce. So this is why I said it's Gauss-Jordan-ish, kind of, sort of. Because you're going to do those row calculations. 2 times row 3, add to the top one, whatever. We're going to multiply and be adding the rows. So now the front half becomes the diagonal ones and the zeros. And whatever you get in the back is going to be your inverse. And I'm sure we're going to all check by multiplying them out to make sure they equal the identity matrix. Sure of it. Okay, so what does this mean for you? Simple enough. I'm going to have the matrix. I'm going to slap on the diagonal ones and the zeros behind it. I'm going to do my row operations to make the front half diagonal ones and zeros. Whatever numbers are at the back half, that's my answer. I'm going to write them down. So here we go. Now, for the sake of space, okay, I'm not going to rewrite this matrix. I just kind of cheated a little bit. I just put my little dashed line in, and I'm going to put my diagonal 1 and zeros in. So leave yourself some room. Now, the goal is, just like we were doing Gauss-Jordan, I want this front half to be the diagonal 1s and the zeros. Whatever numbers I get on the back are my answers. So just like Gauss-Jordan, I work a column at a time. So I'm starting there. I've got the top one. I love the top one. I'm keeping that top corner one. So I'm keeping my top row. Okay. I'm going to change out the 3. Then I'm going to do the -1. So of course 3, we need a -3. So I'm going to multiply the top by -3, add it to the bottom. So the bad news is, okay, We have more calculations to make than in Gauss-Jordan, bless you, because we have to go all the way across. Negative 3 times 1, negative 3, plus 3. Negative 3 times 2, negative 6, plus 7. Negative 3 times 2, negative 6, plus 9. I need longer arms. Negative 3 times 1, negative 3, plus 0. Negative 3 times 0, 0, plus 1. Negative 3 times 0, 0, plus 0. And we carry on, my friends. Now we need to change this negative 1 at the bottom. Remember, you were using that top left one to change it. Man, that's going to be an easy situation. I'm just going to straight add those together. I don't need to multiply by anything. 1 plus negative 1, 2 plus negative 4, 2 plus negative 7, 1 plus 0, 0 plus 0, 0 plus 1. And column 1 is perfect. Moving on. Okay, column at a time. Working on this one. We've got our diagonal 1. We love it. Elliot? Did I miss add?
Oh, no, I see.
Okay. Never know.
Don't mind.
I feel like I didn't space this out very good. I'm going to actually try to move it over a little bit. I feel like it's squished there at the end. Okay. All right, so I'm going to keep my diagonal 1. We've got to change the 2 and the negative 2. Who cares what we do first? I'm going to do the top 2. So I know to get rid of 2, I need negative 2. So I'm going to do all of that row, the whole row, but negative 2. I'm going to add it to the top. Negative 2 times 0, 0 plus 1. Negative 2 times 1, negative 2 plus 2. Negative 2 times 3, negative 6 plus 2. Negative 2 times negative 3, 6 plus 1. Negative 2 times 1, negative 2 plus 0. Negative 2 times 0, 0 plus 0. Got it. Okay, bottom row. Now, I always have kids that are like, can't we just add these together? I'm like, you could, but what's 1 plus 0? You lose your 0 here and you'd have to rearrange that. That's why I always say work on the diagonal 1. You'll never have to go back and recalculate anything. So to get rid of negative 2, let's change this to a 2 now. So middle row times 2, add to the bottom. 2 times 0, 0 plus 0. 2 times 1, 2 plus negative 2. 2 times 3, 6 minus 5. Ooh, I like that. 2 times negative 3, negative 6 plus 1. 2 times 1, 2 plus 0. 2 times 0, 0 plus 1. I'm going to scroll it up. I don't want to be way at the bottom. We got one more matrix to go. One more column to fix. So this guy. So of course I love the diagonal green 1. We're keeping that. That's a win. So fill in the bottom row. And we're going to change the number blue 3 and the red negative 4 above. Doesn't matter what you do, we got to do them both. I'm going to do the blue 3. So to get rid of 3, I need negative 3. So working off the green row, negative 3 times 0, 0 plus 0. Negative 3 times 0, 0 plus 1. Negative 3 times 1, negative 3 plus 3. Negative 3 times negative 5, 15 minus 3. Negative 3 times 2, negative 6 plus 1. Negative 3 times 1, negative 3 plus 0. Okay. Whew, one more row to go. We need to get rid of negative 4. To get rid of negative 4, I'm going to change it to a 4. So I'm doing the green numbers times 4, adding them to the top. 4 times 0, 0 plus 1. We know it. Here's where it really counts, of course. 4 times negative 5, negative 20 plus 7. 4 times 2, 8 minus 2. 4 times 1, 4 plus 0. Whew, okay. So, is your front half, diagonal 1's the identity matrix. So, my final answer is the back half. Now, it's 8th hour, we're tired. I'm not going to just rewrite out those separate numbers at the back half, plus I'm kind of running out of room. So here's what I do. I'm just going to bracket it off, And I'm going to kind of circle it. So just make sure that you indicate that it's just the back half that's your final inverse matrix. Isn't it fun? Hey, let's do one more 3 by 3. I feel the enthusiasm, class. Okay, first up, add on the back the diagonal ones and the zeros. You'll like this one. There's a fraction in it. Nobody? Anybody? Okay. And usually on these, you know, Gauss-Jordan usually took us 4 matrices. These generally you can do them in 3, but it does kind of stink because you obviously have more numbers to work on. All right, column at a time. Top left is the 1. Keep it. Keep your top row. Let's change out the 2. So I'm going to multiply this by -2. And of course, add it in the middle. -2 times 1, -2 plus 2. -2 times -2, 4, minus 3. I like it. -2 times -4, 8, minus 6. -2 times 1, -2, plus 0. -2 times 0, 0 plus 1. -2 times 0, 0 plus 0. Okay. We're on to that -3. So of course, I'm just going to change this to 3. 3 times 1, 3, plus a -3. 3 times -2, -6, plus 6. 3 times -4, -12, plus 15. 3 times 1, 3, plus 0. 3 times 0, 0, plus 0. 3 times 0, 0, plus 1. All right. Now don't let the bottom row scare you because we have a 0 here. Remember, that actually makes our life easier, less calculations to do. We are on the middle column. Now you've got your diagonal 1, winning. We also already have a 0 underneath it, winning. I just need to change out the -2 this time. So I'm going to fill in the green middle row. I like that guy. And I'm going to fill in the blue row because I have the 0 underneath my green diagonal 1. I don't have to do anything. We just need to get rid of that -2. Now remember, you're working off the row with the diagonal 1. So the green numbers, I'm multiplying them by 2 and adding into the top. 2 times 0, 0 plus 1. 2 times 1, 2 plus -2. 2 times 2, 4 plus -4. 2 times -2, -4 plus 1. 2 times 1, 2 plus 0. 2 times 0, 0 plus 0. Whew! Okay. We're getting there. I'm looking at those green numbers. I was like, ooh, man. Okay. All right. Well, column at a time. I need this 3 to be a what? So probably the easiest way to make that happen, remember I said there's going to be a little fraction action in this one, is I would just, let's divide by 3. That's not that traumatic, is it? That 1, 1, oh gosh, a third, ooh, the 4. Let's work with a third, okay? So this time, just so it's nice and pretty, I'm going to rewrite it so it looks all nice and fancy for you. So I'm going to have 0, 0, 1, 1, a third. And just, it's hard for me to erase on the smartboard. It takes so much out. Remember, I don't care if you just cross them off. That's a 1 and a 1/3. And write them, or erase them and just write over them. It's a little easier to do in pencil. Okay, as we're cruising on. Final column to change. So we've got the 1. We have to do some fraction calculations. Ooh, 0 on the top. Win there. I'm just going to fill that guy in a sec. Let's get rid of this green 2. So of course, get rid of 2, -2. -2 times 0, 0 plus 0. -2 times 0, 0 plus 1. -2 times 1, -2 plus 2. -2 times 1, -2 plus -2. -2 times 0, 0 plus 1. Oh, here's the fraction work. Woo! What's -2 times a third? without a calculator. Negative 2/3. Lord help me. Negative 2/3 plus 0. And we don't have to do any calculations on the top red row because you've got the 0 up there. Fill it in. 1, 0, 0. And we have to indicate that our final answer is just which side? The right side. So I'm just going to bracket it off and circle it. So that Gauss Jordan, an inverse of a 3x3, if you ask me, is the worst thing you have to do this chapter. Now, let's show you how to do it. We could have done that all in our calculators, of course. So let's do our calculators. All right, pull up your calculator. You know the drill. I was doing matrices last hour, Greg, too, so I'm ready to rock here. So, of course, you're in your matrix menu. We're going to go over to edit. I'm going to do mine as letter A. Maybe here. And I have to put the size in for mine, 3x3. And just start typing away. And I'm just making sure I don't have any typos on this thing. Oh, I did good. I did all right. Okay. So when you're done, of course, anytime we do any sort of calculations, you have to be on the home screen. So I'm going to quit out. I'm going to pull up my matrix. I did mine as A. So it's already selected. Now remember, on your graphing calculator, this button on the left side, pains me to say this, it's not x to the -1 power. Remember, that -1 means inverse. I just have to hit that x -1 key. That slaps on inverse. I hit enter. There it is. We write it down. So all those row operations we just took 10 minutes to do is done. Isn't that nice? God bless technology.
On the no calculators, the inverse?
There could be one. All right, ready for the next one? Start typing. So same thing, back into my matrix menu. I'm just going to go to edit. I'm doing A, and I'm just going to type over it. Oh shoot, I forgot the negative. I hate this thing. -2, 400. All right, let me make sure I have it typed in right. I kind of looking good. So quit out. You got an answer?
I got an error.
Me too.
There we go.
Me too. So what does that mean?
No.
You can't do it. Now let's talk about the why on that, or what does that actually mean? So you guys would have had a stroke if I would have made you tap my hand. So let's say I'm working on this problem, I can't use my calculator, I'm doing all my row operations, and there is just no way you can get the diagonal ones and the zeros. You can't make it happen. You get a 0 here, you can't make it work out. You get a whole row of 0, something weird happens. It doesn't have an inverse. Every matrix does not have to have an inverse. How awful would that be if I, it'd be fun, we should do it for a challenge. How's that sound? No, anybody? Okay, last thing we're gonna kind of do with this is solve some equations. But we're gonna use our calculators because I think we're kind of hit enough of our row operations. Now, you know I always give you the honest spiel. Here it is. Would I ever solve a system of equations doing inverse of a matrix? Yeah, probably a hard no on that, because I think it's kind of tedious and not really worth it when you have RREF on the calculator. But I'm going to show it to you for whatever it's worth. You can see there's only one problem in the note here. So you can, or what we're going to do, okay, is we're going to write out our system of equations and do 3 separate matrices. Your coefficient matrix, so just all the values on x, your y's, your z's, the variables, and what it equals, okay? Now, if you multiply the coefficients and the variables, you do your row times the column, you will end up back with the original matrix. So just another way to rewrite it. Now, for the sake of time, I just put this on here. Oh Lord, oh, one and four. So we're going to have our coefficients, our x, y, and z, and the number. Now, here's the math behind it. So they're just showing you how you can write it. Your coefficients, the variables, what you equal. If you, of course, put an inverse on the left side, you got to do it on the right, you got to balance. Remember, inverse and the matrix will make the identity. They basically cancel out. 5 and -5 are inverses. They cancel out. So you can, we'll do this in a million years, solve for the variables if you do the inverse of the coefficient matrix times what you're supposed to equal. I don't know. I really don't think it's that exciting. Like I said, it's not really my favorite way to solve it, but I'm going to show it to you for whatever it's worth. So that's what we're going to be doing. Okay? So we're going to do, just to jot it down here, our final calculations, which we're going to use our calculator for. I'm going to do the inverse of the coefficients times what you equal. But let's set it all up here. Let's set it all up. So first, of course, I'm going to write my coefficient matrix. 2, 3, -5, -6. It's a very sloppy -6. Work with it. And then, of course, we're going to write out our variables, which this one just 2. And what we equal, 15 and 36. And remember, when I'm going to click it back a quick slide, okay? So A is the coefficients, the big capital X is the variables, B is what you equal. For us to solve for X, we're going to do the inverse of that coefficient matrix times what you're supposed to equal. I mean, I would just do that with elimination. Would have been done like 10 minutes ago. Yeah. So we're going to do the inverse of the green matrix times the blues. So that is what you would punch in your calculator, which I find tedious. I mean, I could just straight solve this with elimination in like 2 seconds and it would have been done. So I'm not going to bore you with going into matrix on a 2x2 and typing it and doing it. And I'm just going to give you the answer on this because it's tedious. You end up with, when you do this, you get this. You get 30 and 9. So X is 30, Y is 9. I feel like that took an insane amount of work for something that should be super easy. Okay? So that's how you can do it with an inverse matrix. For whatever that's worth. I just thought I should do my due diligence and show it to you. Would I ever actually use it?
So we're not going to do that.
Might be on the review for fun.
Oh my god.
I love it, Owen. All right, word problem. Why not, right? Notice, you know, well, did it get in the hole punch on yours? Like there is a little calculator by it. We're going to do this one in our calculator too. I don't know if the hole punch got it. Oh, why did I make this about rodent food? Okay, pet store owner feeds his hamsters and gerbils. Hamsters and gerbils, fun. Different mixtures of 3 types of rodent food. KD food, pet pellets, and rodent chow. Yeah, good stuff. He wishes to feed his animals the correct amount of each brand to satisfy their daily requirements for protein, fat, and carbohydrates exactly. Suppose the hamsters require 340 milligrams of protein, 280 milligrams of fat, 440 carbohydrates. And then they tell you all the numbers that the gerbils need. The amount of each nutrient in each brand is given in the table. How much should the storekeeper feed his store? Okay, feed the animals. Okay, let's do it. Let's just do it. So basically you're going to have 2 setups, 2 equations happening here. One for the hamsters and one for the gerbils. Let's do the hamsters first. I don't know if I really know what the difference between a hamster and a gerbil is, what they look like.
It's like a gerbil bigger.
Is it?
It's the other way around. I thought you were an animal.
I am, and this is my wheelhouse. Okay. All right, so let's do the hamsters. Okay. So first off, we're going to do this all matrix style, remember, my friends, for the sake of time, too, and our sanity. So you can see they've got all the protein, the fat, they've got it all in the table. So we can just fill that in as our coefficient matrix. 10, 5, 0, 20, 10, 20, 10, 30. Okay. And then of course we've got our variables. I'm gonna use X, Y, and Z. And then of course I gotta reread it, or I should say we gotta reread it. What do we need to total up for the hamsters? Okay, 340 of protein, that was our top row. They need how much fat? 280. And then 440 of carbohydrates. Okay, so remember to do this in your calculator, which we're going to do this one in our calculator. We're going to do A inverse. We're going to type that one in. We're going to do A inverse times B, what you equal. So I'm going to do this all in the calculator, then dear God, we got to do something similar for the gerbils. I know you're excited. Do you mean to type it in or are you typing it in? Let's see what you get. I feel like we should have Jeopardy music playing. Oh, and remind me, I'm going to pass back those quizzes I forgot to ever show you tomorrow.
Okay.
In case I forget again. Why am I putting no one in charge?
Yes.
What am I thinking? What am I doing?
Literally just be quiet.
Probably should
All
just.
you-
I'm better off writing it down on a post-it note.
Alex, shut up.
The reason we're gonna get a bagger
It's really you, but
is our, what was it called, odorless?
yeah. You wanna pitch our idea to the class, Alex?
Oh Lord, I'm scared.
No, what you do.
So you should end up with a 3x1 matrix answer. What did you get in that 3x1? 10,
10, 3, 12.
10, 3, 12 you should get. Okay, so Lord help us, we still got to do the gerbils. So, but for the sake of the story problem, so the 10 means, of course, we're doing 10 milligrams of the KD food. Milligram of KD. We're doing 3 milligrams of the pet pellets. Pet pellets, I can't talk. I just want you to know the price of chicken feed's gone up, and I'm not very happy about it. Okay, and then 12 milligrams of the rodent chow. That really sounds appetizing. And now, I'm going to scroll it up because we got to figure out the amounts for the gerbils. We're still going. Okay, gerbils. But I think we can do it with not a whole lot of work. Okay? Because for the gerbils, is this A matrix going to change? No. You already have it typed in. Keep it. I'm not even going to rewrite it. We got it. Do your inverse on it, of course. But our B matrix changed. Because we have to, well, I might have scrolled it off. I don't know. It might still be up there. How much the gerbils require is different. The gerbils require, did I cut it off? No, it's still up there. 480 milligrams of protein. They require 360 fat and 680 carbs. So keep your A in there. You've already got it. Just change B. And again, you'll get a 3x1. Right here, 8, 4, 20. So again, I'm story problem. We got 8 milligrams of the KD, 3 of the pet pellets, or sorry, 4 of the pet pellets. Isn't this fun? And 20 of the rodent chow.
No, didn't pick them.
Okay. We're talking about our brackets.
Yeah.
Okay.
Yeah, mine brackets already.
Not good. Any questions on your calculator, any issues on the calculator? Isn't that fun? Okay. So it is kind of a mix of stuff.